All right, welcome back to Chapter 1, Lesson 1. I am now on page 7, so this is the third and final video for this lesson. Now, this one's going to be a little special. Most of them are only 2. We're going to do some practice problems here, and I'm going to show you from questions. I'm just zooming in and out. From questions 1 to 7, and then I'm going to have you guys practice on your own. See, I've learned from my mistakes from last year. I used to do all the problems and then that didn't leave anybody any practice. So I'm going to leave you guys some practice problems. The top half here is always very similar to the bottom half where you can get some practice on your own. Just making this so I can now edit on here, and we're going to fill in this chart. Now charts like this are very helpful. They give you a visual of what things are going to look like. So when it says to complete this, when we're looking for a pattern here on how it's counted. So we have a cube as a single number. A long, this is just 10 of these little cubes. A flat is 10 sticks of this long one pushed together. And then we go to cube again, which is 10 of these flats smushed together to make a group of 1,000. So when we're looking for the pattern here, we're going to go cube, long, flat, cube, long, flat. And then if you think about how big a cube of 1 million of these little guys would be, that's a lot of cubes. So now that we have the number of groups, so in the ones place, it's just a single unit of 1. In a group of 10, this is 10 groups of 1. In the group of 100, it's 10 groups of 10. In the 1,000, it's 10 groups of 100. In the 10,000, it's 10 groups of 1,000. In 100,000, it would be 10 groups of 10,000. And finally, in a million, it would be 10 groups of 100,000. So the key here is to recognize that each jump is times 10. 1 times 10 is 10. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10, 10,000 times 10, and 100,000 times 10. All of these are increased by a multiple of 10. When we get into this a little further, we're going to find out when we divide by 10, we go down a place value. A million divided by 10 is 100,000, then 10,000, then 1,000, then 100, then 10, then 1. That's a little later. All right, so here's the real lesson here. So we're going to be looking for the value of the underlined digit. Now this can get confusing from place value. Place value is ones, tens, hundreds, thousands, 10,000. The value is the actual value of just this number. So here's my little trick. I'm going to bring my 7 down. I'm going to see how many numbers are to the right of this. And I have 1, 2, 3, 4, 5. So I'm going to include 5 zeros. I'm going to place a comma between the hundreds and the thousands place. And the value of the 7 is 700,000. The value of the 4, same idea. I'm going to bring the 4 down. I have 1 digit to the right. It's going to remain a 0, and the value of the 4 in the tens place is 40. Same idea here, 182,034. I'm going to bring that 8 down. I'm going to count all the digits to the right. I have 4 numbers to the right. So in my value, I'm going to put 4 zeros. I'm going to put a comma between the hundreds and the thousands place, and the value of the 8 is 80,000. Same idea here, 345,890. I'm interested in the 5. There are 3 digits to the right. I'm going to include 3 zeros. Comma is optional at 5,000. And this is the value of your underlined digit. So 2 more questions here. We're going to wrap this up. Compare the value of the underlined digits, 2,000 and 200. So a couple things here. The word is going to mean equal. The word times is going to mean times. Is equals times multiplication. So the value of 2 in 2000 is 10 times the value of the 2 in 200. And that is just another fancy way to say that 2000 equals 10 times 200. So that is the actual number sentence for what you are describing up here. The value of 4 in 400 is 10 times the value of 4 in 40. And again, 400 is 10 times 40. So this is just another way to put in words this expression for 400. 10 times 40 is 400. So 400 is 10 times bigger than 40. All right. So I'm going to close this snippet sketch here. I'm going to show you the rest of the page. You are on your own. It even says, on your own. Use the information that we just did. Complete the bottom of this page. And let's take a quick look at the next side. Now, I know I told you in class today that question number 17 is going to become a quiz, so I'm not doing that on video. Let's take a look at a word problem because people freak out on word problems. It's not even that hard. 14. What is the value of the digit 7 in the population of Memphis? How many times as much is the value of the place that the 7 is in than the value of the place to the right? So, and actually I should have read a little bit more. Use a table for question 14. That looks good. We're going to use that kind of goldeny yellow orangish table right there where it has city populations. That is a table of information. And we're going to look here at Memphis. So, what is the value of the digit 7 in the population? Right there. How many times as much is the value of the place that the 7 is in than the value of the place to the right? Well, hopefully you've been listening. So the value of the place to the right is 10 times less. So when we go to answer this, the value of the 7 is going to be 70,000. And how many times as much is the value of the place to the value of the place that the 7 is in than the value of the place to the right? So it's 10 times larger. So from the 6 to the 7, it's 10 times larger. Excuse me. How many models, and number 15, how many models of 100 do you need to model 3,200? So I'm going to give you a little hack on this one. I used this before in a different video. So the fact that I have 3,200 and I want to know how many hundreds make 3,200, this is technically a division problem of which I'm going to show you like this. Now again, this little hack only works when you can stack your zeros. So I have zeros in my ones place, I can cancel them. I have zeros in my tens place, I can cancel those too. Once I hit the 1, I can't do any more, I'm done. I'm going to circle what's left of my top, and that's going to give me 32. And you need 32 groups of 100. How many models of 100? 32 groups. Of 100 equals 3,200. Notice how that 32 is related to 3,200. You can see that 32 already in that number. Moving on to question 16. Sid wrote 541,309 on his paper. Using numbers and words, explain how the number would change if he exchanged the digits in the 100,000s place and the 10,000s place. So 100,000 to 10,000. I'm going to give you a little work over here. I'm not going to do this whole one for you. So the 5 currently is 500,000, and the 4 is 40,000. I'm going to switch colors. If I switched these two, I would then have 400,000, as the 4 would now be in the 100,000 place, and the 5 would be in the 50,000 place. Did I do that wrong? I probably did. 15 to 100,000. I did the 10th place. Okay. Well, the 500,000 was still right. I think you're still going to catch on to this. But that's why you should read your question more than once. I did 10,000s, 100,000s, and the 10s. Okay, the 10th place is 0. Well, that's going to make this a little easier. So if I put 0 in the 100,000th place, it's 0. If I put a 5 in the 10th place, it would be 50. So instead of having 541,309, I would have 41,359, where I changed the 5 here for the 5 there. Makes a big difference in that number. If 16 is giving you problems, even after I've explained this, made a mistake, and re-explained it, don't worry too much about it. It's really just working on the place value. We will probably go over this one in class pretty extensively, so you shouldn't have any problems. All right, I'm going to close this out. 17 is going to become a quiz, and good luck. Just check your place value. All of these are going to ask for a value, and then you're going to have to check it to see if it's right. All right, guys. Well, this is a great way to start our videos. I'm going to post this in Class Dojo, and I'm going to post this on my YouTube channel, so you can go check it out. A lot of videos on math and language arts. Yay. All right, have a great evening, everybody, and we'll see you tomorrow. Bye-bye.